Okay, this video is on section 6.4. So you're going to watch this video and then you'll have some time to work on the homework. So we're still talking about vectors, but now we have something called a dot product. And this is how we multiply two vectors together. So far, the only thing we've done is multiplying a vector by a scalar. So that would be like if we had this vector, 2, -5, and I multiplied by this scalar of 3, you would just distribute the 3 through and you would get 6, -15 as a vector. It would still be a vector. Well, this time we're going to multiply two vectors together, and that's called the dot product. And this dot is on purpose really big. That's what dot products look like. So here's what you do. You just take the first two components, the A and the C, and you multiply them. And then you take the second two components, the B and the D, and you multiply them, and then you add it all up. So in our first example, if I'm taking the dot product of 4, -1, and 2, 5, I take the first two x components and I multiply them together. And then I take the two y components, multiply them together, and then add them up. So I'll have an 8 plus a -5, and those two together will make a 3. See how this time I wound up with just a number versus up here when I took a vector times a number, I got another vector. This time when I take two vectors and I find the dot product, I get just a number. Your answer will be just a number. Okay, so over here, take the first two parts and multiply them. Take the second two parts and multiply them. And add them up. So I will have a 16 plus a -16, and that's equal to 0. So my dot product is 0. That will have a meaning in a few slides from now. So that's just the dot product. Now we can use the dot product for things. Well, actually, we'll just skip to that page. So you can use the dot product to help you find the angle between two vectors. This is your formula for the angle between two vectors. The angle is right here, but in the formula it's cosine of the angle equals the dot product of the two vectors divided by each vector's magnitude multiplied together. Now just keep in mind, in order to get this angle all by itself, you're going to have to do the inverse cosine of all that stuff, the dot product on top, the two magnitudes multiplied together on the bottom. You want the angle, so you're going to have to do the inverse cosine to get it. Okay, so let's set this formula up. The dot product goes on top. So I'm going to multiply -2 times 4, and I'm going to multiply -6 times -3, and we're going to add those up. That goes on the top. On the bottom, we're going to do the magnitude of v. Okay, the magnitude is when you take the square root of the x component squared plus the y component squared. That would be the magnitude of v. Now we need to do the magnitude of w. So I would take the x component, square it, and the y component, square it. Okay, so let's clean that right side up a bit. This would be a -8 plus 18. Down here, this would be a 4 plus a 36. So that would be the square root of 40. This would be 16 plus 9, so that would be the square root of 25. So on the top, I would have a 10. On the bottom, if you want to just leave it as the square root of 40 times the square root of 25, you could. You don't have to worry about simplifying this part at all because that's not your final answer. Your final answer is just theta, so you have to do the inverse cosine of 10 over square root of 40 times square root of 25. And when you type that all in your calculator, you'll get your angle of 71.57. Okay, if you're a visual person, if I was to draw these two vectors, -2, -6, that would be the vector right like this. That would be -2, -6. The other vector, 4, -3, would be to the right 4, down 3, so right about here. So what we just found was the angle between those two vectors. Here, I'll try to get a different color. This angle between the two vectors is 71.57 degrees. Okay? Going back to this slide, this is just some practice with notation. So for part A, you're going to take vector u and you're going to multiply it by the dot product of vector v and w. Always do the stuff in the parentheses first. So we're going to do the dot product first. So we're going to take v and w and find that dot product. And vector u is just going to hang out in the front for a little bit. So I'm just going to copy that down. 1, -3. Just going to hang out there for a bit. Okay, the dot product of v and w, we're going to do -2 times 1 plus -6 times 2 okay, copying down that vector u again. Now when I take a dot product, I wind up with just a number. So this would be a -2 plus a -12. -2 plus -12 is -14. So now I have a vector times just a number. So you can distribute that -14 through. So -14 times 1 is -14. -14 times -3 is 42. And so I end up with a vector. So here's kind of what you need to know. The dot product is just a number. It was -14. When you take a number times a vector, you get a vector. In part B here, if you took vector u and did the dot product with 2 times v, that would be the same thing as doing the dot product first and then multiplying by 2. They would be equivalent things. So if I took vector u, 1, -3, and I did the dot product with 2 times vector v, 2 times this, 2 times -2 would be -4, 2 times -6 would be -12. So if I found that dot product, I would do 1 times -4 plus -3 times -12, and I would have a -4 plus 36, which ends up to be 32. Well, okay, let's compare that to the second statement where we're going to do the dot product first. So the dot product of u and v. Okay, so u was 1, negative 3, and v is negative 2, negative 6. We're going to find the dot product of those. Okay, so 1 times negative 2 plus negative 3 times negative 6 I would have a negative 2 plus 18, right? And negative 2 plus 18 is 16, and 2 times 16 is 32. They are equal to one another. Okay, the last thing for you to just kind of know, and this is on your vector sheet, is that the dot product of u and u is the same thing as the magnitude of u squared. This is just kind of a property, and it's on your unit circle sheet. Okay, moving on. You can also use dot products to help you figure out if two vectors are parallel or orthogonal. Orthogonal is just another word for perpendicular. So if you want to just use perpendicular, you can. That means they hit at a 90-degree angle. So if the dot product is 0, that means two vectors are perpendicular. So let's try the dot product of these two, the dot product of u and v. So we would do 2 times 6 plus negative 3 times 4. Okay, and we would get 12 plus a negative 12, which is 0. So since the dot product was 0, they are perpendicular. Perpendicular means they hit at a right angle. If you were to graph these, just to kind of confirm, 2, negative 3 would be going to the right 2 and down 3. So something like that. And 6, 4 would be going to the right 6 and up 4. So maybe like that. And can you kind of see how those look like they are perpendicular? You can kind of tell. I would never go just based on the graph because, you know, you could be just a terrible drawer and it may or may not look like 90 degrees. Just try the dot product. If the dot product is 0, that means they're perpendicular. The book loves to use this word orthogonal. Just know that those mean the same thing. Okay, the last thing to know is vectors u and v will be parallel if one vector is a multiple of the other vector. So let me give you an example. Let's say we have one vector 1, 3, and we have another vector 4, 12. Do you see how if you multiplied this vector by 4, you would get this vector? 4 times, whoops, I don't want to use parentheses. 4 times this vector, 1, 3, makes 4, 12. One vector is a multiple of the other vector. That would mean they're parallel. So let's check this example. If you don't like the i's and the j's, you can change it into component form. So 15, 45. And we can change this one into -5, 12. Okay. Are they